Hello and welcome students. This is Indefinite Integration lecture number 11. Integration lecture number 11. Okay, in this lecture today we are going to see some very important results which will help us take the topic ahead. And what those results are? Those results are integration of 1 upon square root of x square plus a square dx, where x square and x square is a variable square. Definitely, if we are writing dx, we are integrating with respect to x. So we have x as a variable and a is a constant. So we are going to see how do we integrate if we have any such result. We have any such problem. For example, I give you an example for this. Suppose you have to integrate 1 upon square root of x square plus 25 dx. So what would you do? You will first write 25 as 5 square and then you will apply this result. So you will not be able to integrate this unless you learn this result, you learn this theory. So this is one that we are going to see. And second, we will see integration of 1 upon square root of x square minus a square dx and 1 upon square root of a square minus x square dx. So these three theories we are going to do today in the lecture. And my dear students, this is going to be very interesting and it's really fun learning these three theories. Okay, and in most of the boards it is found that they ask these theories in exam, that how are the results derived. Okay, so I just tell you example like this one. When we will solve, you will notice that integration of 1 upon square root of a square minus x square is coming as sine inverse of x over a plus c. What is the integration of this thing? The integration of this thing is sine inverse of x over a plus c. So there is a complete derivation which we are going to see, and this derivation comes in exam in some of the boards. Okay, so we will learn how to derive this, and this comes for 3 marks. In some boards it might also come for 4 marks. So it's a very important part that we are going to do today. What are x square and a square in these results? I have already told you that x square is a variable square and a square is constant square. So you have the first one, you have x square plus a square under square root in the denominator. In the second one, you have x square minus a square under square root in the denominator. And the last one, you have constant square minus variable square, that is a square minus x square under square root in the denominator. So these are three results that we are going to see this. We are going to learn today. These three theories, we are going to derive their integration and then we will take problems on them. So let's begin. Let's begin. Okay. So students, if you remember when I taught you derivative, and in derivative, there was one section in which we did the expressions and substitutions. We had done expressions and substitutions. If you do not remember that part, I would request you that you find out and do it. Expressions and substitutions. So what I mean is, like, we had done that when we have we see an expression where we have square root of 1 minus x square. So in square root of 1 minus x square, okay, if we see square root of 1 minus x square, then we put x equals to sine of theta or x equals to cos of theta. Now, why this expression? Why this substitution? Why this substitution? The answer is very simple, that this substitution. Why this substitution? The answer is very simple, that this substitution, because if I'm using such a substitution, then this helps me remove the square root. Now, how does it help me remove the square root? It is because when I'm putting x equals to sine theta in this expression, okay, x equals to sine theta in this expression, I end up with a formula. I end up with a formula 1 minus sine square theta, or for that matter, even cos theta, if I substitute here, I end up with a formula 1 minus cos square theta. Other than these two substitutions, for this expression, the other substitutions will not work. Okay, you putting excess sec theta or excess cosec theta, tan theta or cot theta will not work here. Yeah, they definitely work in some other substitutions. Okay, so if you have, you remember, if you have 1 plus x square, then you substitute, you put x is equal to tan theta, or you substitute x equals to cot theta, because now these two substitutions will help us get the formula. They will help me get the formula, and then the square root will be removed. The main aim for using the substitution is to make the expression easier. Okay, remove the square root, and then we had x square minus 1, where we put x equals to sec theta or x equals to cosec theta. Some students take this substitution part very lightly. My suggestion to all of you is that you make sure that you learn these things by heart. You learn these things by heart. Okay, there are so many things which you have to remember, and once you remember, you start working on them, and then you, at one point in time, you start realizing that yes, I did a great job by remembering, because now I am understanding. Okay, so square root of 1 minus x square, this all we know. So students, today we are going to have a small change here. Now what is that change? Let me tell you. Okay, for if some of you are thinking that why are we learning this expression and substitution, because we were doing that integral of those results that I told you. So for them, I need to tell you that we are doing these expressions and substitutions because these expressions are going to help me solve those results, those theories. Okay, so we are going to, you can check, you can see that we have got square root here, we have got square root here, square root here, all square roots are there. So we are doing these expressions and substitutions because they are going to help us in those theories which we are going to see today. So there is a small change here, students, and you know what that change is? This one, I want you all to now consider this one as 1 square. Can we treat 1 as 1 square? Definitely yes. Can we treat 1 as 1 square? Yes, 1 is 1 square. And now remember, students, I want you all to see it in a different perspective. Now 1 square minus x square, put x is equal to 1 sine theta and 1 cos theta. It is actually this way. I repeat again. Okay, so the earlier which I would tell you that it is 1 minus x square under square root. Now you should understand that it is not 1 minus x square. It was 1 square minus x square. What it was 1 square minus x square. Okay, and the substitution was, when it is 1 square minus x square, it is x equals to 1 sine theta or x equals to 1 cos theta. Now what I'm asking you all to do is replace this 1 by a. Okay, replace this 1 by a. So if you have square root of a square minus x square, then what would be the substitution? Very simple, my dear student. The substitution will be, put x is equal to a sine theta or x equals to a cos theta or x equals to a cos theta. Now some of you might be thinking whether this is going to work, because our aim was to, what was our aim? Our aim was to make the expression simpler by using this. So if some of you are thinking that is this going to work, so my answer to them is yes, definitely it is going to work. So here what it was, x is equal to a sine theta or x equals to a cos theta, and yes, it is going to work. So how does it work? Let me now show it to you. So students, when I have, here it is, okay, here it is. So when I have square root of a square minus x square, I put x as a sine theta. See, how does it work? Okay, so square root of a square minus x square, and what is x? X is a sine theta. So it is a sine theta square. Okay, so it is square root of a square minus a square sine square theta. Now taking a square as a square common, so I get 1 minus sine square theta, and 1 minus sine square theta is cos square theta, so it is a square into cos square theta, and therefore you have a cos theta. What do you have? You have a cos theta. See, the square root is removed. Now you taking a into account, x as a sine theta, when you take a into account, what happens is you get the square, you get the square of both. You get the square of a, you get the square of sine. So a square sine square theta. So by taking this a into account, you actually are making a provision of taking common. See, because now you have a square here, so you could take a square common. Outside there was a square, so now you could take a square common, and because that a square is out, you are left with 1 minus sine square theta. I'm sure this is very simple thing for you, so you all must have understood. So this is the change that we are going to have. When we have square root of a square minus x square, what would be the substitution? X is equal to a sine theta or x equals to a cos theta. That is the substitution. Okay, that was really interesting. Okay, next. The next is root of 1 plus x square. So what change we are going to have here? It is, okay, first of all, it is not 1, it is root of 1 square plus x square. And here what's happening? We are now writing 1 as a. So a square plus x square, square root of a square plus x square. So when we write square root of a square plus x square, what is the substitution? The substitution is put x equals to a tan theta. Earlier what it was, my dear students? It was x is equal to tan theta. Tan theta is 1 tan theta. Okay, and x equals to 1 cot theta. But now 1 is being replaced by a. That constant is a. Okay, so x equals to a tan theta, or x is equal to a cot theta, or x equals to a cot theta. So here we have x as a tan theta, or x is equal to a cot theta. And will this be helping us remove the square root as earlier? Yes, definitely yes. Okay. And I feel no importance of writing the whole illustration once again. If some of you want to do it, I would suggest you that you do it on your own. Okay, you do that on your own. And similarly, what is final, my dear students? Here, like it is x square. The third one is x square. Okay, let me put these stars over here so that you will know that this is something that you have to focus on. Okay, and then finally, square root of it is square root of x square minus 1. As I told you, 1 should be treated as 1 square. 1 is 1 square now. So here it is square root of x square minus a square. Okay, so what would be the substitution? The substitution is put x equals to, yes, you are right, someone said, I heard it, a sec theta. Okay, I was just joking, how could I hear you? Okay, so x is equal to a sec theta, or x equals to a cosec theta. X is equal to a sec theta, or x is equal to a cosec theta when you have x square minus a square. Let me put these stars because this is what. Okay, so students, I request you to make a note of this. Okay, you see the earlier notes you have already written in derivatives. So here today, what you should do is you should write the one which are with stars. Okay, so please do it. Please copy this. So here, students, we are going to begin with the first theory in the set of 3 theories which I just showed it to you. Okay, so what is the first one? What was the first one? The first one was integral 1 over square root of x square plus a square. Okay, so I would write this as I. This is my assumption. Let this integral be equal to I. This is my assumption, and this is the first one. Okay, it's the first one, right? So here, as I told you, if I see square root of x square plus a square, what do? I do this, I make the substitution. X is equal to a tan theta. Now, what's the reason for this substitution? Very simple. I substitute this because I want to make this square root disappear. I just want to make this simpler. That's it. What more can I do? So at this stage, I just want to see something which is simpler than square root. I would prefer not to have a square root over a square root. I just prefer not to have a square root. That's why this. So next step. Okay, fine. Next step. What is my next step? Remember, students, you are planning to remove this square, this x, you are planning to remove this square, and in this place of square in your integrand, you are planning to remove this x. I'm sorry, you are planning to remove this x, and in place of x, you are planning to write a tan theta. So remember, if you are writing a tan theta there, this differential dx will not work anymore. You will have to have d theta, the new differential, that is d theta. Okay, definitely a is a constant, theta is a variable, a is a constant. So what is next step we do here after substitution? As usual, we will differentiate. Okay, so here I write differentiating with respect to theta because I wrote x as a tan theta. When I differentiate with respect to theta, I get d by d theta of x, and here I have d by d theta of a tan theta. Now, as you know, students, a is a constant, so out d by d theta of tan theta is sec square theta, d by d theta of tan theta, sec square theta. But here I have dx over d theta. So next step, what will happen? Dx, and this theta I multiply here, I get a sec square theta d theta. A sec square theta d theta I get. Okay. So the next step is this much. What is, so I now write the new integral. Okay. So the new integral will be completely transformed into theta. So 1 and then square root of, it is x square plus a square. What is x? X is a tan theta. So I have a tan theta square plus a square. And what is dx? Dx is a sec square theta d theta. A sec square theta d theta. Fine. So next step, I get 1 upon square root of. Okay, what did I do, students? For x, I substituted a tan theta, and for dx, I substituted a sec square theta d theta. Now, square root of a tan theta square, which is a square tan square theta plus a square, and here it is 1 into a sec square theta d theta. So, you know, when you multiply 1 to any number, you get the same number. So here I have a sec square theta d theta. And down here in the denominator, a square is common. I get tan square theta plus 1. Tan square theta plus 1. So here I have square root in integral a sec square theta d theta. And here in the denominator, I have a square, and tan square theta plus 1 is sec square theta. Fantastic. So here next step is, see, next step is I equals to integral a sec square theta d theta, and here down I get, see, square root of a square sec square theta is a sec theta. I get a sec theta. What happens next is a cancels and sec theta, one sec theta cancels, so you are left with sec theta in the numerator. So you have I equals to sec theta d theta. This is what you are left with. And students, you know what is integral of sec x dx? Integral sec x dx is log of sec x plus tan x. So here it is sec theta d theta. So log of mod sec theta plus tan theta plus a constant, and the constant I add here is C1. Okay, I know some of you are thinking why C1. Don't worry. I could have written C. If you write C, it is still okay, but I'm writing C1 for some reason. So you also just wait for it. So I'm adding the constant as C1. Okay, fine. So as such, integration is over, students, but the theory is far from over. The integration here is over. The integral part is over, but the theory is still not over. The reason is, if you check, the given integral was in x, the given integral was in x, and what have you done? You have written your final answer in theta, which is not over. So definitely you need to have the answer in x. You are not supposed to write your answer in theta, you have to write your answer in x. So what should I do? Yes, I tell you. Here is the substitution which we made. This is the place where we made the substitution. So I shall come back once again there. I will come back there, and I will come back there, and with the help of this I shall get the value of sec theta and tan theta. In my final, in this, here at this stage, what am I getting? I'm getting tan theta and sec theta. You can check. I'm having here sec theta and tan theta. So what I will do is, from the substitution, I shall find out the value of tan theta and sec theta, and which I will substitute here. Okay. I will not leave my answer in this. I cannot leave my answer in this theta. I will have to convert the answer into x. So that I will do. So let's begin. So I write here from 1. I write here, see, what do I write? I write from 1. I'm using the different color. From 1, x upon a equals to tan theta. Oh, that's great. That's great. So here, let me write this as number 2. This is number 2. This is equation number 2. Okay, in which we will make the substitution finally. So from 1, I got x upon a as tan theta, and this is number 3. So students, where you have tan theta, what would you write? You will write x upon a. Remember, we will come back to this. Tan theta, where we have, we will write x over a. But it is still not over. Why? Because we want to write sec theta 2. I want to write the value of sec theta. So for sec theta, how do I calculate? I will use the formula. I write here, we know that sec square theta is equal to 1 plus tan square theta. 1 plus tan square theta. So sec theta is, okay, sec theta is square root of 1 plus tan square theta. And that tan theta we have already calculated. What was tan theta? We have already found tan theta to be x over a, right? So I write, so 1 plus x over a square. So I get sec theta as square root of 1 plus x square upon a square. That is square root of a square is LCM. I get here a square plus x square. This is my sec theta. Okay. So next step, what I will do is I shall write sec theta. Okay. I shall write here sec theta equals to, writing the separate square root, it is a square plus x square in the numerator, a square plus x square in the numerator, and denominator is a. Okay, this is number 4. This is number 4. What will I write now, students? I will write using 3 and 4 in 2. Using 3 and tan theta we got from 3, and sec theta we got from 4. We will write using 3 and 4 in 2, right? So I write here using 3 and 4, 3 and 4 into, we get, what do you get? You get here I equals to log of sec theta plus tan theta it was. You remember sec theta plus tan theta? So log of sec theta. What is sec theta? Sec theta is this. So it is square root of a square plus x square, which is same as x square plus a square, upon a plus tan theta. Tan theta was x upon a plus c1. Okay. Next step. Now, as I see the common denominator, I write here a and square root of x square plus a square plus x, okay, plus c1. Now students, as you all know, this is numerator and denominator is a log of m upon n. Log m upon n is log m minus log n. So this is, I have log of square root of x square plus a square plus x minus log of a plus c1. And tell me students, what was a? A was a constant. So if a is a constant, log a is a constant, and here already a constant. So what I will do is this whole constant I shall replace by another constant which I will write as c. I will write that as c. So that was the reason earlier I wrote c1. Okay, so I get here log of square root of x square plus a square root of x square plus a square plus x plus c. Okay, where c is minus log a plus c1. So I write the final answer. Therefore, integral 1 over square root of x square plus a square dx is equal to, it is equal to log of mod of x plus square root of x square plus a square plus c, where c is negative of log a plus c1. This is it. So you are now, once again, you are having one more result. Okay, in the set of results, now you have one more result which you can use. You can see the whole theory once again in order to learn it better. Thank you. So after doing 1 over square root of x square plus a square, next we are going to do 1 over square root of x square minus a square dx. 1 over square root of x square minus a square dx. We are now going to take this one, and after that finally we will take 1 over square root of a square minus x square dx. We will do this. So let me do this first. So I write here 2 and I take that as I equals to square root of 1 over square root of x square minus a square dx. Okay, so let's go for the substitution. As you all know students, this we have already done. What was the substitution for x square minus a square? The substitution was x is equal to a sec theta or a cosec theta. I will prefer sec theta, a sec theta I will prefer. Okay, I will prefer a sec theta. So here I write, put x equals to a sec theta, and as you know, if you do the substitution you have to also differentiate. So I write here differentiating with respect to theta. Okay, so d by d theta of x on the left and d by d theta of a sec theta on the right. So I have dx by d theta is equal to a is a constant out, and d by d theta of sec theta is sec theta into tan theta. I multiply d theta here, so dx is equal to a sec theta tan theta and d theta and d theta. what I do next is, now I write the new integral. The new integral will be in theta completely. So I equals to 1 dx, 1 here, and dx 1, and then dx. For dx, what do I write? I write a sec theta tan theta d theta and divide by x square. What is x? X is a sec theta. So a sec theta square minus a square. So the next step I get is a sec theta tan theta d theta divided by, here under square root, I get a square sec square theta minus a square. So I get here a sec theta tan theta d theta divide by, I take a square common. So a square is common. I get sec square theta minus 1, which is a sec theta tan theta d theta divided by square root of a square, and sec square theta minus 1 is tan square theta. So I get here I equals to a sec theta tan theta d theta divided by a tan theta, square root of a square minus a square into x square, a square into tan square theta. So when the square root is removed, you get a tan theta. What you will get next, this a is cancelled and tan theta is cancelled. So you have once again sec theta d theta. I equals to sec theta d theta. And as you know, students, integral sec theta d theta will be log of sec theta plus tan theta plus c1. Okay, I write this as number 2. This I write as number 2, and this is not the end of the theory. It is only end of the integration. Now we don't have to integrate anymore because we are done with the integration. This is equation number 2. Okay. But then what I notice that in this I still have sec theta and tan theta, which I need to remove and write in terms of x. So where will I get that from? I will get it from this. So here this is equation number 1. This is equation number 1. Now I write from, so I write here from 1, x over a equals to sec theta. So I got the value of sec theta, which I will use. This is my third equation. This will be used in 2 for writing the final answer. What more I do now? Sec theta, I have obtained sec theta, but I still have to find tan theta, right? This tan theta. So tan theta, how do I find? I find tan theta with the help of formula. I write here, we know that sec square theta equals to 1 plus tan square theta. So tan square theta would be, tan square theta is sec square theta minus 1. So tan of theta is square root of sec square theta minus 1, right? So I now substitute tan theta. I substitute sec theta. What is sec theta? Sec theta was x over a. You can check. Sec theta was x over a. So I write here in the formula x over a square minus 1. So it gets me square root of x square upon a square minus 1. This is tan theta. So I get here I get here tan theta equals to a square is LCM, and you get x square minus a square. You can write the separate square roots. Writing the separate square roots, you get square root of x square minus a square over square root of a square, which is a, and this is equation number, I read this as equation number 4. This is equation number 4. So you have equation number 3 giving you sec theta, equation number 4 gives you tan theta. What is next step? I will write here using 3 and 4 in 2 we get. So what do we get? I get here I equals to log of sec theta. What was sec theta? X over a plus tan theta. What was tan theta? Tan theta was square root of x square minus a square upon a plus c1 plus c1. You know the reason why we write, oh, here I had not written c1. No problem. I write it now. So here, as you know, students, here we are writing c1 because this c1 we will later make it. We will make this c1 later c. Okay, so plus c1. Now finding the denominator common, I would be adding the numerator. So I get log of mod of x plus square root of x square minus a square over a plus c1. So I have here I have therefore I equals to now I will use the logarithmic law, the quotient law. Log of m upon n is log m minus log n. So I have log of x plus square root of x square minus a square log m minus log n minus log of a, because a is the denominator. So log x plus square root x square minus a square minus log a plus c1, and minus log a plus c1. In the next step I will substitute it as another constant, because a is a constant, so negative of log a is also a constant. So I will get log of I equals to log of x plus square root of x square minus a square plus c, where c is negative log a plus c1. Okay, this is, so if you write the final step, you will have to replace I by square root of 1 upon square root of x square minus a square dx equals to log of mod of x plus square root of x square minus a square plus c. This is the second one. This is result number 2 in this theory. Okay, you can please see this once again in order to have a quick revision. You can see it as many times as you want. Thank you. Okay, students, so after this theory, we will take the third one, and the third one is integral 1 upon square root of a square minus x square dx. This is the final one. Integral 1 upon square root of a square minus x square. So I write here the third one. I make an assumption for the integral to be I write let I equals to 1 over square root a square minus x square dx. 1 over square root a square minus x square dx. Then I write here put x, the substitution is put x is equal to a sine theta. I have already explained you why this substitution. I write differentiating with respect to theta. and I get d by d theta of x equals to d by d theta of a sine theta. So I have dx upon d theta equals to a, and d by d theta of cos of theta. D by d theta sine theta, d by d theta sine theta is equal to cos theta. Now next step, this d theta will multiply here. I get dx equals to a cos theta d theta. We will write the next step as we will write the next step as I equals to integral 1 dx, 1 and dx. What is dx? Dx is a cos theta d theta. A cos theta d theta divided by a square minus x square. A square minus x square. X is a sine theta. So I have here a sine theta square. A sine theta square. So I have I equals to a cos theta d theta divided by square root of a square minus a sine theta the whole square, which is a square sine square theta. So I get a cos theta d theta, and in the denominator square root I take a square common. I get 1 minus sine square theta in the bracket, 1 minus sine square theta. So I get a cos theta d theta, a cos theta d theta divided by square root of a square into cos square theta. So this gets me this gets me I equals to integral a cos theta d theta, a cos theta d theta divided by a cos theta. So a cancels, cos theta cancels. I am left with I equals to 1 d theta. So this is I, and 1 d theta is theta plus c. This is equation number 2. Here it is 1. Okay. So my integral is over, definitely, but the theory is not yet over. Why? Because I'm getting the final step in theta, but I need to write the final answer in x. Why so? Because the given integral was in x. The given integral was in x. So if the given integral, you can check here, the given integral, if it was in x, the final answer should also be in x. So here I write from 1. I write here from 1. X over a is sine theta, because I had substituted x as a sine theta. So I get sine of theta is equal to x over a. Sine of theta is x over a. So theta equals to sine inverse of x over a. And this is my 3. I write using 3 in 2. I write here using 3 in 2. We get what we get, students. We get I equals to theta plus c. So this becomes, therefore, I equals to theta. Theta is sine inverse of x over a plus c. And what is I? I is square root 1 upon square root of a square minus x square dx equals to sine inverse of x over a plus c, x over a plus c. This is the final theory which we proved. This is the final one that we proved just now. Okay. Now, students, what I will do is I will write all this theory at one place. I will write them all at one place, so that, and I will give you an idea to remember these theories. Okay, so let's begin. What was the first one? The first one was The first one was integral 1 upon square root x square plus a square dx. The second one is 1 upon square root x square minus a square dx. And the third one is 1 upon square root a square minus x square dx. Okay. So first of all, I shall teach you how do we. I shall want you to uh, read these theories as follows. You should always say, square root x square plus a square is referred as variable square plus constant square, variable square plus constant square, variable square minus constant square, and constant square minus variable square. So remember, student, that among these three, the third one has its answer. The third one has its integral completely different from the rest two. Okay, so first of all, that has to be kept in mind, that the third one is totally different amongst these three. And what is that? It is it is sine inverse of x over a plus c. Okay, and the rest two, they resemble each other. The integral of these two, the first one and the second one, is they are looking, they look alike. They are not same, but they look alike. But the third one is totally different. So this is first thing that you will keep in mind, that when I have square root of constant square minus variable square in the denominator, the answer is different from the rest two of its type. So here, and what is this? What do we write for them? Say these two, the integral, they resemble each other. Here you have log, then mod plus c. Here also you have log, then mod plus c. Okay. What more? Now inside the inside the mod, what you have is variable. What is variable, students? Definitely x. X is the variable. So inside the mod you have x plus the square root which you have in the denominator as it is, as it is, as it is. So see how simple it is. X plus square root of x square plus a square. And here also what it is x plus, and the square root in the denominator as it is. So x square minus a square. Okay. So very simple, students. Once again, you can see this once again. Let me do the whole thing once again for you. So the third one, as I said, is totally different. It looks different. So here it is what? Sine inverse of x upon a plus c. So if you have a square minus x square, constant square minus variable square, the integral looks totally different. But whereas the two are concerned, these two are concerned, they resemble each other. What is the resemblance? The resemblance is both of them start with log, both of them start with log and plus c, log plus c. Okay, what's inside the mod? Mod is very simple. You have two terms. One of them is the variable itself. Variable itself. What's the variable? X. So x plus, and then the square root which you have in the denominator, you write it as it is. So square root of x square plus a square. And same here. What it is? It is x plus square root of x square minus a square, because the square root in the denominator is having x square minus a square. So this is it. Practice it well. Students, we have done very important three theories. In next, we will do some problems based on this. Thank you.